Thank you, Michael. Thanks. So Michael's father often told him as a child in Sri Lanka, "You only disappear from this earth when the last person on it stops thinking about you. That as long as someone is thinking about you, you're alive and well. And that's why some are immortal. Einstein, Newton, Beethoven, Picasso, so many more." That idea stuck with Michael, and he wanted to leave something behind, a body of work that he's passionate about and that contributes to the world, his life's work. Michael had a vision for this book, a vision he put to paper as an outline for the first time on August 3rd, 1993, more than 18 years ago. He remembers that exact date. He remembers it distinctly, and he worked constantly over 18 years to finish the book, fully aware, in his own words, that only a madman would undertake such an enormous task. So, as an editor, and maybe a madman in my own right, publishing, to me, is about risk-taking. Michael took a risk 18 years ago, deciding to put his life's work to paper, putting all of his career eggs in one basket, and any academic ambitions on hold. Schlumberger, the multinational oil field company he's worked for 27 years, encourages innovation, supports science, and heavily invests in research, much more so than other oil companies. Other oil companies wouldn't have been so supportive, especially because this book was such a large time commitment. Michael, having solved 950 of the 1,000 equations in the book, in fact, all on his own and all from scratch. This book is unusual in so many ways, innately in its subject matter, 1,000 solutions to just one equation, in its large format, all 2,000 pages of the book, in its commissioning of 1,000 illustrations to link its 125-page table of contents to more than 1,000 equations, in its publication itself, a business decision whether to commit to such an unusual book, a book outside the box, or so to speak, a book so voluminous it could crush the box. So what is this book? I have a story for you, a story about how this book came about, a story as unique as the book itself. You see, there's this equation in math, science, and engineering. It's called the diffusion equation. As you might imagine, it models diffusion mathematically. So what are we modeling? What is diffusion? All diffusion is, at its core, is the spreading of a substance from higher concentration to lower concentration. That's all diffusion is, but it's a phenomenon that intersects our daily lives. Heat diffuses a metal. It causes expansion and contraction. So civil engineers use the diffusion equation to figure out how much space to leave between the joints of a metal bridge or a train track, for example. Tumor growth occurs through a diffusion process, and biomedical engineers use the diffusion equation to understand cancer growth. Using the diffusion equation, financial risk can be modeled probabilistically. Even the age of the Earth has been determined by solving the diffusion equation, the first time in 1864 by Lord Kelvin, in fact. There are countless ways to use the diffusion equation to solve our everyday problems, and that is precisely where Michael's book and the diffusion equation come in. So, enter Michael Thambanayagam, straight out of college as a rookie chemical engineer, working in a research lab for the Department of Industry in the UK, and then for British Petroleum. Michael started working on pressure diffusion, in short, how to tap an oil reservoir when the oil is embedded in rock, under intense pressure and deep within the earth. The diffusion equation is used to model just these types of pressure scenarios, but it typically takes months to solve problems such as these. As a research engineer, Michael had to solve these problems from scratch, starting anew each and every single time. Early on, Michael started to solve these problems unconventionally, with a method called integral transform, a very straightforward mathematical approach. He quickly learned that he could save enormous amounts of time solving these problems, and solving these problems fast. At about that point, Michael realized he should start compiling his efforts, the scores and scores of solutions to different diffusion equation problems. Over time, Michael's employers became his cheerleaders, so supportive of him at every step of the way and recognizing the tremendous time-saving value in his work. So supportive, in fact, that Michael worked his way up the ladder, managing labs and becoming the managing director of Schlumberger Cambridge Research, the crown jewel of the company. So finally, Michael outlined his book then on August 3rd, 1993. Over the next 18 years, he worked programmatically through permutations and combinations of conditions, solving and compiling over 1,000 variants of that one diffusion equation. But then what? What comes next after solving 1,000 equations? Michael came to his last year working on the book, and in his words, that last year was torture. How would he go about organizing 1,000 solutions to just one equation? How do you do that in a book? Then came the defining moment, that aha moment. To the untrained eye, 1,000 undifferentiated differential equations, connected visually by 1,000 icons. Aha, it's a picture book. And therein lies the secret to how engineers use this book. It's a picture book. A biomedical engineer developing a treatment for pancreatitis, let's say, needs to model diffusion of calcium in the pancreas because calcium clumps and forms stones there, which causes pain and infection. That engineer identifies the three-dimensional parameters of the diffusion problem she needs to solve to come up with a novel treatment. She refers to the illustrated 125-page table of contents in the book, looking for the icon that visually represents her conditions, and then she refers to that specific solution within the book, where the icon and the equation are expanded upon, with a fully worked out solution to the problem. So how to get to this organization? Michael developed a whole new nomenclature, a visual map that would group and link together the different kinds of equations. Over the course of a year, he sat one-on-one with a graphic artist to render this new nomenclature in the form of one-dimensional, two-dimensional, and three-dimensional icons. Many days, Michael thought he should just wake up, delete all of his book files, forget all about it, and pretend he never started it. And I bet he's glad he didn't do that. It was a tremendously difficult process. It was a risk career-wise. It was a challenge personally, and it seemed at times to take over his life. He'd always come back, though, to his father's words. He wanted to leave something behind, something valuable. And what would Michael tell his children? Because half their lives, half their childhoods, they saw him in his basement study in Connecticut, working on his book. He had to finish it, in his words, to tell his children, to tell his father, too, that he's leaving something behind. Sitting in his basement study, Michael often wondered, how would he finish this book? How would he get it published? Would any publisher be crazy enough to publish a single equation in 1,000 different forms? Michael thought it would be hard to get the book published. No, I think he knew it would be hard to get it published. He wanted McGraw-Hill, though, to publish his book because of our long history in engineering publishing. When I first saw this book, I knew we had to publish it. Michael convinced me, and I had to convince my team to do such an unusual book, to take a risk, and that's kind of what it's about. Michael convinced me that this book of 1,000 solutions is an incredible achievement in and of itself, but add to that a whole new nomenclature and method to characterize groups of equations. It's remarkable. We'd find a way to publish it physically and financially. So, R.R. Hawkins was the chief of the New York Public Library's Science and Technology Division, and he was devoted to the publication of technical books and knowledge, a Renaissance man. And this book is a renaissance of sorts, a tremendous achievement in the technical and engineering literature, so it makes winning this award in Hawkins' honor all the more special. McGraw-Hill is a proud publisher with a long history, and this honor adds richly to our deep pride. It's the first time McGraw-Hill has won the Hawkins Award, and in fact, it's the first time the PSP has given the award to a picture book. So, on behalf of McGraw-Hill Professional and Michael Thambanayagam, thank you. Thanks.
Well done. Well done, buddy. Well done, absolutely. I get the picture. I get it. I want to thank you all for coming here today and for making these awards what they are. I want to congratulate McGraw-Hill and Michael on their very well-deserved win and tell you all that I will see you here next year for the 37th Annual PROSE Awards. Thank you very much. Thank you.